Okay.
Yeah. Philip Stan, please start your presentation, be the second in the series. And we join every participant to please uh, mute their mic. Thank you, Philip.
Okay. Let me see. I will have a few screens to share today. So hopefully the switching between these will work. Maybe if something you don't see, please remind me and I will try to switch it. Yeah. So let's switch first now to the presentation. I will try to share this now. Let me see. So now you can see my screen, hopefully. Yes. Wait, internet is slow. Wrong button again. So you can see my screen, hopefully. Yes?
Yes, I can see your screen.
Okay. So now welcome to the part 2 of our analog and digital. And now we are talking today about scanning and what's all about. Just let's review, we will have a small review of the part 1, what we had 2 days ago. We'll talk about 3D dental scanners, the workflow, how it works. I have prepared some real cases after. We will see how much time we will have. And we will also have a conclusion afterwards. So just a small review. We had last time compared, sorry for some mistake here, compared the analog and digital workflow. We had breakdown of the wages costs. We had talked about how we should start. And now we will go more in the dental scanner. This is where we left last time, where we start, because to go digital, you need definitely a dental scanner. So what kind of scanners do we have? What are in the dental field? Because if you go on the internet and research for the 3D scanners, you will find thousands of different scanners for different types of solutions, like small toys for your desktop to do some small designing things, to very expensive ones for a couple $10,000. So let's break it down. For the dental field, we have first of all desktop scanners, what is actually for us now in the laboratory the most common way. And we have 2 different categories. One is contactless. That means our object, what we scan, will not be touched by the scanner. It will actually take photographs of it and then after matching it to a 3D model. But we have a second type of scanner. It's a it's a one with a contact. We call it tactile. For example, the Renishaw scanner, what we find, I think from UK, the scanner comes. This kind of scanner we need if we want to have a higher precision, especially on objects what are reflecting like metal. Then we have another group, this are the intraoral scanners. This you'll find mostly in the dentist area. The difference is that you can directly scan in the patient's mouth and hold in your hand to freely objects. This is very common, especially in designing or also in the automotive sector. And for us, is check the contactless scanner like this one from the Shining 3D DSEX. They have 3 different desk scanners on the market. This one, then a more sophisticated one, the DSEX Pro, and the Mix. The Mix is that from last year on the market. Pro, and this one is already longer on the market, and it's a very good scanner to enter the digital dentistry. It's not a high price, very reliable, and you can do a lot of things. The light source with desktop scanners can be a laser or striped light, what we will have here. As you can see, we have a light source in the middle, and then we have 2 cameras. The method, like I said, is triangulation. Sorry for my, and we have 2 cameras and the light source, and we can use it to scan any kind of plaster model. We can scan impressions. We can scan dies. We have a multi-die platform, and we can scan also other objects. We have a free scan mode where we can scan of, for example, a denture, to duplicate a denture. Or maybe you want to do some toys for your kids. You can scan and replicate them, or import something and modify it in FreeCAD or something like this. Yeah, this scanner here has not such a high resolution of camera. It has 1.2, 1.3 megapixel cameras, but it can scan also in color. And the accuracy of, in general, of this scanner is around 15 microns. The DSEX Pro will have below 10, and the Mix is even more precise because it has up to 5 megapixel cameras, what gains in a very nice precision and nice scan result. The desktop tactile scanners is something like this. We can see you have a needle what will go around the object to measure it. The advantage of these is we can scan a metal surface without any scan spray. Because to capture a metal surface like a telescopic crown or a bar, we need to use a spray so it doesn't reflect when we use a normal scanner. Therefore, this surface is not precise anymore because there's a layer of scan spray on there. And in this type of scanners, you don't need this. And in the industry, they use it making quality control to see if this milled object, maybe a motor block, has the same dimensions what they're supposed to have. So we have a higher accuracy, and the accuracy is around 20 microns. Intraoral scanner, for example, like this one, this is an intraoral scan 3, the newest model from Shining 3D on the market. Also here you have a light source and a mirror who will capture it. It's usage for intraoral. Like I said, we have color scan also, and below 40 microns now. Handheld scanners look like this. You also have a light source, and you can scan faces, objects, or the whole people, the whole person if you want to. Also available in color scans and up to 40 microns. So how does now actually the digital workflow goes? We always need to create an order in our software. In our case, we have 2 options. We can use the Dental Manager from Shining 3D and then scan our objects and go to Exocad for the designing, Or the second option would be we enter our case in the Dental DB and scan and design after our cases. Both software like the scan software and Exocad are connected. So each way works fine. So we 3D scan our objects. In this case, we will use the DSEX. We will make a 3D design in Exocad. Definitely, there are other design softwares out there. For example, 3Shape has a software, very good one. We have Zerona, they have one. We have Circo and Zahn, they have now their own version. And we have, of course, Dental Wings and Blender for Dental and lots of stuff on. After we have to do the nesting of our objects, what we have designed in the CAM software, sorry for here. And then we have the manufacturing part. We mill it on a CNC 4 to 5 axis. We can 3D print our objects with a filament printer, a resin printer, or laser melting. And we have also the hybrid between laser melting and CNC. And definitely after, we need to finish our crown. So in the real world, let's say we have an anterior crown, we have a posterior crown today, and I will have a small flexible denture. Yeah. So how we go with crowns and bridges? Normally the analog way, we have the model management, we make the antagonist, the master cast, we have a section models, and normally I do a control model too. We put everything in the articulator, we do our framework, we wax something, we cast, and we finish the metal. And after we put some porcelain or composite. But how does it work digitally? Sorry, small mistake. So we have also the model management. When we use Plaster, the same part, we also do an articulation if we need to. And with the framework, we have more options. We can just scan something. We can mill it in wax, for example, and cast. If we're looking at the PFM crowns, or option 2 could be we scan and design, we're milling it directly, and after we finish. Of course, it depends, of course, on your milling unit, what you are able of to do. If you have a smaller mill, you maybe can only mill wax, zirconia, or PMMA. So you cannot mill the metal coping. But if you have a bigger one, maybe you can also mill from cobalt. And of course, we have to finish it. If we do this in desilicate, we have the same thing. Model management, articulation, we wax, we press, we finish. After, if we need to, we put porcelain, no composite. Digital, the same thing. We can have again option 1 and 2. We can scan, design it, mill it in wax, press it, and finish. Or we can directly mill something out of a lithium disilicate block, sinter it after, and finish it. And of course, option 2 will save us some time in the whole process. Veneering, the same thing. So if you have a crown and bridge now in zirconia, if you want to veneer it, same thing again. Yeah. If you do it the analog way, we have the possibility to use a copy mill. For example, Circo and Zahn has one, or maybe Amann-Girrbach you will find also somewhere. I still have one. What is the way I started? But here also you have to modulate your coping or your crown in a resin. You copy mill it in a zirconia block, sintering finish. And if you need to veneer it, porcelain on top. Digital, the same thing, model management again, articulation. And here we can have also a scan design. We made it ourselves, entering, finishing it. Or for example, you can outsource this. If you have no mill, you can outsource this to maybe mill center, and you don't have to worry about this whole process. Of course, you have to pay someone for that, but like I said before, you don't have to worry about it. It's like with dentures, for example, you also buy your acrylic teeth somewhere. You don't manufacture them by yourself. So you don't have to worry about the quality or anything. You buy it where you want to, where the price is maybe to your satisfaction. And of course, after you renew it again. The full contour zirconia, for example, you can actually do only in a digital way. I have tried it also as a copy mill, but the outcome is not so nice, and I would not recommend this. I know some people did this in the beginning, but I don't think this is really up to date anymore. Yeah. So for the digital world, we do then the model management again, the Mastercard section, the articulation, and so on. We scan the same again, or do it ourselves or outsource. And after you just stain and glaze, you save a lot of time with this kind of work. I will show you an image after how it looks. The flexible denture we also have in the analog way, the model management, the mastercast. So duplication, normally it's duplication model. We have an articulation, we set up everything, we do the modulation, flasking, boil out, injection, and after polish. It's very time consuming, and if something not is working out, you normally start from the beginning again. In the digital world, if you get, for example, an intraoral scan, like I will show you after, you don't have a model anymore. You have a virtual model. Of course, you can print this if you need to. So you don't have to do the MasterCard. You don't have to do any duplication. So you save materials and time on this one. On the model, if you don't need to print something and you don't need to duplicate something, you don't need to block out or use any silicone or any agar agar to duplication. Articulation, if you need to do it, you can do it virtually. And the denture process, you scan. If you have a model, if not, you just import the file, you set up virtual, you block out virtual, everything is virtual, and then you can mill it out of a CNC machine. I use CNC milling for the base and the teeth, and also you can, of course, print nowadays the base and the teeth maybe also. And after, you just need to check the fit and of the base and the teeth, and you combine everything together. So the conclusion is you have different scanners and software on the market, and you need to select these requirements on your budget and what you want to do. If you have a smaller budget, the DSEX, for example, is totally fine. You can do your crown and bridge work, you can do your chrome dentures, you can do your acrylic dentures, you can do also single implants. All of this is possible. And also you can use your articulator in this scanner, what is very useful. If your budget is higher, then you go for a more expensive scanner maybe. Or if your requirements are higher, like you have lots of implant cases, you need a higher precision, and then you maybe go with a DSEX Pro or the Mix. We can replace the analog way partial or full. in this way, we can gain a more efficiency in our lab and more precision, definitely. And it's more reliable. Because if I put something on the mill tonight, like a denture, I can mill it overnight and I come back next morning and it fits. Yeah, I don't have to sit half an hour or 1 hour to deflask something, to clean, to take the plaster out, and so on. Maybe there's a bubble or something, I have to fix it. It's very precise, and the efficiency is minimum of 50% higher than analog. And on top of that, you can source your work if you need to. If you don't have a mill, you can send it to someone to mill it for you. Or if you don't have a module, for example, the partial model in Exocad, you can also send the scanned models out. Somebody else does the design for you and to get it back. And this way you can offer more stuff, more solutions for your clients by not investing anymore. You just take what you need and pay somebody, a freelancer, what you want to have. In this way, you don't have to invest a lot of time and money, maybe in trainings or staff. And also your staff can focus more on maybe the aesthetic finishing than on wasting time on frameworks and all of these things. So you are shifting fixed cost to variable cost, because then you just pick what you need. So let's get a bit practical now. I will try to share now the photos. What I will, let me have a minute here to change the screen. We take this off and we go here. For example, this is a crown what we will scan now, a model what as an old model what I have done last year or so. I just kept it for demonstration. We did back then, I think, PFM or on Emacs, I don't remember exactly, but we will scan this now today, and I will try to show you the workflow of the whole process. Let me put now the other one. Also, this case, sorry for all the bubbles, but something went wrong there. It's a molar crown, what we just did now last week. And it looks after like this. A full contour zirconia crown milled out of a multi-layer block, just stained and glazed. No porcelain on there, nothing. Yeah. And from the flexible denture, I don't have a photo now, but I can show you something else. For example, zirconia crown, what we milled in zirconia, a multi-layer block, and after sintering, you can see it becomes a tooth shade, a little bit smaller because of sintering, but as you can see, in this case, you just try to make the fit, and you're good to go. You put your stains and your glaze, your chip occlusion for your proximal contacts. You can imagine how much time you will save on this case, comparing it to layering some porcelain. For anterior cases, normally we put porcelain a bit because it's more aesthetic. So let me start Exocad now and share that screen. So far, any questions? Anything what you want to know?
Philip-san, thank you. I think you're not done with your presentation. I'm trying to encourage guys to put any information in the chat box so that we can ask you, but I'm here to hear from them. Please go on.
So you can see my Exocad screen here. Hopefully.
Yeah, your Exocad screen is seen.
Okay, good.
Very
So
well.
what we can see here is the screen from Exocad's Dental DB, it's called. So on the left side, you see all the details of client's name and so on. In the middle, we have our screen for selecting what we want to do. And on the right side, we have the action buttons, finally, to calibrate, scan, and so on. So we always have to enter the client, we have to enter the name of a patient. Technician is not needed, notes are not needed. We have to select the case, what I just did now, and let's do a coping. In the middle, we have a selection of materials, what we want to do. This is important because you can have different parameters according to your material, yeah, of cement spacer or minimum thickness of the object, it can vary. So let's choose a normal zirconia and leave all these parameters like it is. You see, we can see in the middle now a coping. If we would have an antagonist, we can select this, but we don't have at the moment. Yeah, we can select an antagonist. It will also show in the middle. And then you should have to select other things as well. Let's clear this out. We save, and then we scan this. So let's see if our scan screen will come up. You can see the scan screen now?
Yes, I can see it, and I hope others can.
Good, because I was not sure if I have to share this also. So now we have the dialog for settings for the scanning. We have a separated model or non-separated model, and we have a select an artificial intelligence scan. It's a bit more precise. And we don't have more now because we don't have anything else to scan. Normally, if you would have an antagonist, you could select maybe articulator and all these things. So we leave it as it is. Yeah. And we go on next. I have to spray a bit of spray here on this one. Just to make sure we can scan this. So the software will give you, the scan software will give you an advice what to do. On the left upper corner, you will see the image of the scanner, what it sees. So we can see now our model in the scanner. On the right side, it will give you the instruction what you have to do. So for example, we have the upper door, put it in. So we scan that. Because I have scanned this already, it will ask me if I want to use what's there. Let's say no. We scan again. You see, it goes quick. We just make a quick scan. This is an overview of the whole model. Unfortunately, I'm not able to show you the scanning process itself because we only have one camera here connected. So I cut now out what is not necessary. And then it will ask me to put my die in the multi-die platform in the middle. Some more spray. As you can see it now in the left upper corner, you see my die from the model, and I just put scan. and it will scan now this plaster die. The advantage of the higher scanners for the DS-EX Pro or the Mix, they are faster than this one and more precise. But for normal crown and bridge work and to start into dentistry, this is totally fine.
Okay, Philip, we can only see your ESOCAL screen, and that hasn't changed. I can see.
Oh, okay. Maybe. Sorry for that. I didn't know.
That hasn't changed for a while.
Okay, this is what I was asking. So let me go back quick. You can see my screen now?
Yes, you can. Yes, you can see it now.
Okay. So let me repeat this then.
Okay. Okay, we can see that you're trying to, your laptop, you're trying to scan something beside the laptop or something.
Yeah, just let me repeat this. So you see this is the scanning dialog. So on the left upper side, you can see the preview of the object, what is going to be scanned. On the right side, you see the instruction, what the scanner wants to do now. So he asked me now to insert the upper jaw, what I just did now. And because I have scanned, it will ask me if I want to use what is already there or I want to rescan. So let's rescan now. Hopefully you can see it now.
Yes, we can see, sir.
Yeah,
okay.
I see the
So now the scanner is scanning this model from different sides to get an orientation and overview. This scan is not so precise, it's just there that we can allocate after our preparated die. Okay, so with this slider here, I can now cut out what I don't need. Yeah, like this. I click on next. And because we have no antagonist, he will ask me now to put in this tooth. And as you can see, it also shows the number of the tooths. So if you have multiple dies to scan, it will show you which one goes in which place. I click next. And it does the same thing. And now it will go do a more precise scan of our plaster die. And as you can see, it goes very quick. And it doesn't matter really if you have 1, 2, or 8 in this disk, because it's the same time. So if you have a bigger case with a bridge, it goes really fast. So the scan is finished. And again, I will cut off what I don't need. Okay. On the right side, we have a few options. If you see somewhere where there's a hole or somewhere, or there's nothing scanned, you can do a manual scan. You just turn it. Yeah. The instant scan is like make different images from different perspectives and do this automatically. So I don't have to use the manual adding scan button. It's a bit easier. Yeah. Again, we can, like I said before, we can cut off what we don't need to go next. Now we will see the matching of the die very quick. You can see now it's put perfectly here in the spot where it belongs to. You can see it on this greenish yellow overlapping. It's kind of equal, it's not turned, it's in the right position. Of course, you can do also manual aligning if you need to. So now it's complete, and we case we just leave it. And also, if you see here a hole somewhere, we can fill this hole up, as you can see, and we can proceed. We can click on design because the software is connected to Exocad. Oh. Yeah, can you see this turn model here? Okay, I hope so. So where the margin is. You have a small can point to your margin. You click on the margin and the software will select automatically. If this is not perfect, you have the way to correct it. Then this line is turning green, and we can make adjustments. We can add points and correct this if we need to. Let's go next. So now we have the crown bottom. That means the inside of the crown. No, it's not correct really. It's the spacing, the cement spacing. What we normally use in the analog world, we put a die spacer, kind of varnish on our die to create some space for the cement later. Or if we have to block something out, we apply wax or some kind of resin. We have different parameters. They are the same what we have in the settings. We can define borders.
Phillips, please, can I interrupt you?
Yeah.
Can I interrupt you?
Sorry?
Can I interrupt you?
Can you what?
Yes, I want us to have a break for 2 seconds. We'll come back for just 2 minutes. Okay. We'll come back so that we can really conclude this meeting well. Okay. Yeah, thank you. 2 minutes, ladies and gentlemen, we'll be back.